Just like when we factored binomials, the first step in factoring trinomials, the process is always going to be to take out a GCF first. So we always want to do GCF factoring. And then beyond that, we're going to do what I call a trial and error factoring process. Now, that makes it sound like, well, we're just going to try a bunch of things, and you can do that, but we're going to use some techniques that kind of give us some targeted practice into breaking up these specifically quadratic trinomials into the product of two linear binomials. So a quadratic trinomial, what we're going to be working with primarily will look like this. And it's going to, when we factor it, be the product of two linear things that would look something like, mx plus b, and let's just call this dx plus f. Two linear factors that would multiply together to be a quadratic factor. And we're all good at multiplying them together. We can do that flawlessly. Working it backwards is a little bit more complicated. So first thing we always want to do is look for a GCF. We worked this problem yesterday. You don't need to write it down. Again, we took out a 2x, right? And I'm not super interested in problems like this because why? Why am I not interested in that necessarily? In the context of factoring trinomials. This is not a what? What's the degree of this term? The degree of this expression? It's a third degree expression, right? And I just told you we're going to be primarily factoring ax squared plus bx plus c, right? But we can take a GCF out of this nonetheless. We could take a GCF of 2x out, and when you take out the 2x, you end up with 2x squared plus x minus 4. And then we would need to see, since we're factoring trinomials, if this could factor any further, right? It can't, because 2 times negative 4, which is negative 8, does not have any factor pairs that add up to be positive 1. Okay, and we'll use that relationship that we just saw when we multiplied those things together. There's no factor pairs of negative 8 that would add up to be positive 1. Negative 2 or 7. That's 2 or 7 is the only differences that we could get there with those terms. All right, so that one can't factor any further, and all we could do is take out a GCF. This is even a little bit more off the beaten trail, but it is a trinomial. Can we take a GCF out of this one? What's the GCF? 3x squared y, right? We could take everything has at least 2 factors of x, and everything has 1 factor of y. Right? We take that out, what would we have left in the first term? 2xy cubed. Then you can do a quick check of that. If you multiply that back together, you should get what you started with, right? And you do. Plus 1, right? We have to have that 1 there because if I multiply this back together, I have to get what I started with. So I have to guarantee that I'm going to get that term back when I multiply it. And then finally, minus 4x squared y to the, what? 4th. This is just pure skill set here. There's no practical application for an expression like that. You'll never have to graph anything that looks like that. You'll never have to solve anything that looks like that. This is just practicing the skill of GCF factoring. So we won't do a lot of that, but wanted you to see it. Most of the factoring that we're going to look at, because it's interesting to us, is factoring like this: x squared plus 5x minus 6. Now, I know from the pretest that I gave you that you guys can handle this quite well, right? What's the process? Describe what we do here to factor this. What are we looking for? Katie, we're looking for what multiplies to be negative 6 but adds to be 5, right? Positive 5. What are those two factors going to be? 6 and what kind of 1? Negative 1, right? So we need a positive 6 and a negative 1. Because this always starts, we're always going to end up with 2 linear factors. It's good. Draw 2 parentheses, and then we got to fill in the blanks. We know that x times x will give us x squared. And then we're looking for the factors of negative 6 that add up to be positive 5. Now, what's the trap here? What two numbers might you try to use that aren't going to work? 2 and 3, right? Because 2 times 3 is 6, and that's the key. 2 times 3 is positive 6. 2 plus 3 is positive 5. If you add these, you get positive 5. If you multiply them, you get 6. But the problem is it's a positive 6. We don't need positive 6, we need negative 6. So the only factor pair that's going to work here is positive 6 and negative 1, excuse me. Now we can do a quick check, right? X times x is x squared. X times x is x squared. X times 6, that's 6x. This is minus 1x. And then negative 1 times 6 is negative 6. And everything works because 6x minus 1x gives us that 5x that we started with, and it's good. Always, when you factor, always check it. And as a matter of fact, the method that I'm going to show you, the check is built right into the process. Okay, I'm going to show you kind of how to trial and error your way through this pointedly, but to get the right answer. Excuse me, Charlie. All right, so we check it and get what we started with, so that's our answer. Now this shows you why you couldn't have used 2 and 3. If you used 2 and 3, then you would have gotten negative 2, and negative 3 would give you positive 1x, which is not there. And that's why this method is called the trial and error method, because it's okay to try things, and if they don't work, you pick something else. You pick other factors of negative 6 that will work. All right? Now, let's have a look at x squared plus 8x plus 15. This one's a little easier, right? There's no negatives involved. Everything's nice and positive. So what are the factors of 15 that add up to be 8? 3 and 5, right? So if we kind of do this and give it a quick check, we know that x times x has to be here, and then this could be 3x, and this can be 5x, both positive would give us 8x. Both of these positive would multiply to give us 15, and that's it. That works. Okay? So these are nice and easy. They can get a little bit more complicated if we're dealing with negative numbers and positive numbers, so let's look at a few of those that have some little bit trickier things to think about. Try this one. X squared minus 10x minus 24. What's the trap on this problem? You want to do 6 and 4, right? Because 6 and 4 is 24, 6 and 4 is 10, but 6 and 4 is not going to work, is it? If you tried 6 and 4, to get a negative 24, one of these would have to be positive and one of them would have to be negative, and that would give you 6x minus 4x. 6x minus 4x is not negative 10x. That's not what we're looking for, right? So the factorization that will work, the only factorization that will work is what? Negative 12 and positive 2. Okay? Negative 12 and positive 2 will work, and will give us x plus 2 times x minus 12. Hooray! This is the correct answer. Yeah. Is everybody good? This is easier stuff. Then we move to something that looks like this. 4x squared plus 3x minus 1. Now we're no longer looking for the factors of the last term that add up to be the middle term, right? There are no factors of negative 1 that add up to be 3. This is where that combination of things goes in or comes into play. So here's how I want you to approach this. We know that it's going to factor into two binomials if it's factorable, right? And we also know, because we've multiplied like 100 of these two things together, that this product plus this product is going to have to add up to be 3x. That middle term is going to come from those two things. So that's kind of setting the plate for what our format's going to look like. Every method, circle, slide, divide, the x method, whatever is going to involve multiplying this number times this number. 4 times negative 1 is negative 4. And we're looking for the factors of negative 4 that add up to be positive 3. What are those two factors? 4x and negative 1x, right? So these two products are going to be 4x minus 1x. Have to be. Right? Now what those two numbers tell us is what has to come out of these two products. So I've got to put something here to get 4x squared. And what's different about this problem and the previous problems is I have choices, right? What are my two choices? I could use 2 and 2, or I could use 4 and 1, right? Will 2x and 2x work? Will 2x and 2x work? Why not? Because I can't use 2, I can't multiply 2 by any integer to get negative 1. So again, I was telling you, these two things drive everything, and they do, so I have to use 4x and x here. 4x and x is what I have to use. So I multiply this 4x times something over here to get this term. That would have to be what? Plus 1. So 4x times 1 is 4x. And then x times negative 1 would give me the negative 1x. And negative 1 times 1 is negative 1. And that's the correct solution. You can ask Siri. She'll tell you it's the correct solution too. Okay? So this is what I call the unfoiling method. We're just doing this in reverse. Let's have a look at another one. Let me click through this. All right. Have a look at this one. 4x squared minus 8x minus 12. How many circle, slide, divide fans are in here? Do this problem by circle, slide, divide. I mean, it's a nifty trick. It has some benefits to it. I think it gives people an opportunity to learn a difficult skill in an easy way, but it's not super efficient because it leads you down the wrong path in some instances. All right, so if you start this problem just by doing circle, slide, divide, you'd multiply that, right? And that gives you negative 48. So we're looking for the factors of negative 48 that add up to negative 8, and that would be what? Negative 12 and positive 4. So we would do x minus 12, x plus 4, and then divide. We have to divide by the same number we multiplied by in the beginning. And then 12 divided by 4 is 3, and 4 divided by 4 is 1, right? But what's x times x? Is that what we started with? What did we start with? We started with 4x squared, didn't we? Negative 3 times 1 is negative 3, but we didn't start with negative 3. We started with negative 12. So what happened?
You just divided 4 by 12 instead of reducing the fraction. Like it should be 3 over 1. Or like
Yeah, 3 over 1. So here's what happened. In this problem, and this is one of the instances, guys, this is one of the instances where if you follow circle, slide, divide by the book, it messes you up. All right? You have to take the GCF out first. If you don't take a GCF out first, your factoring method falls apart. Now, the good news is that the zeros are still the same. So if you did that by circle, slide, divide, and you did what we just did, the zeros are still the same. And that's a good thing. But it doesn't give you a complete factored expression. So first we have to take out a GCF, which in this case would be what? 4. And that'll give us x squared minus 2x minus 3. And then I don't have to do any kind of circle, slide, divide. My leading coefficient is 1. I'm looking for the factors of negative 3 that add up to be negative 2, and that would be x minus 3 times x plus 1. So here's what we lost doing circle, slide, divide. We lost the GCF. So that's one caution. If you're going to use circle, slide, divide method, you have to take out the GCF first or you miss the problem. And that's why I don't love the method, because any method where you can do everything right and still miss the problem is bad. Okay, that's not a solid method. Okay, so 4 times x minus 3 times x plus 1 is what we end up with there. All right, let's have a look at this one. 6x squared minus 17x plus 12. Now, even if we're not using the circle, slide, divide method, it's extremely important to check for a GCF always. That's the first step of the process. So always check for a GCF. Does this one have one? It doesn't, because 17 is prime, so we don't have any GCF to worry about. I'm going to start with my binomial times binomial. Test 1, 2. Okay? All right? Every method, circle, slide, divide, every method that you've learned up to this point in your life is going to require you to multiply this times this so we can get an educated guess of what those two middle terms are going to be. What does negative 17x bust up into? What are those two pieces? 6 times 12 is 72. What are the factors of 72 that add up to be negative 17? Negative 8x and negative 9x is what we're looking for. Okay? All right? Now, these two terms, the negative 8 and the negative 9, are going to give me an idea of what needs to go here and here. All right? What are my options for 6x squared? Can I use 6x and x to get 8x and 9x? No, why not? Because 6 doesn't go into either of those numbers, right? So I have to use, it forces me to use what? 3x and 2x. Or you could use 2x and 3x, doesn't matter. So that takes care of the 6x squared. Now this 3 is going to multiply over here by something to get one of these numbers. It's not 8, right? 3 times negative 3 is going to give me negative 9x. And then 2x times negative 4 will give me negative 8x. And then what's negative 4 times negative 3? Positive 12. So that term just kind of takes care of itself. And in the process of working the problem, I've checked the problem. Everything's multiplied together, everything works. All right? And this is just trial and error factoring, or unfoiling it. And it's faster once you get good at this. This is the fastest method for factoring, so it just kind of gets together all. It wins out in all forms. Okay, let's have a look at this one: x squared plus 7x plus 12. What would that factor as? X plus 4 times x plus 3, right? That one's easy. What about this one? Maybe not so easy. By any method. Wrestle with this one for a second, see what you can come up with. Let's go. What's the answer? What'd you get, Brittany?
5x minus 7 times 3x plus 4.
Yeah, that's right, because this is negative 21, and that's positive 20, and those add up to be negative 1, right? And that's negative 28. All right, now let me show you a shortcut, or what I consider to be a shortcut for finding this, these factors. What is 15 times negative 28? What? Negative 420. Does that help us really? I mean, that doesn't really help us, does it? So instead of ever multiplying those two numbers together, just dance with who brung you, right? 15 is the phrase of the day. 15 and negative 28 is what we're going to work with. Break 15 down. 3 and 5. Break 28 down. 7 and 4. Okay? Now, we're looking for a combination of those factors that we could multiply to give us a 1, negative 1, right? And if you look pretty clearly, you can see that 7 times 3 is 21, and 5 times 4 is 20. So when we break this thing down, what we're looking for from our middle terms is negative 21x and positive 20x. We can also see pretty clearly right here that the factor pair combinations that we need to use for 15x squared are 3x and 5x. And that the 5 has to multiply by 4, and that the 7 has to multiply by, negative 7 has to be multiplied by positive 3. Now what's 4 times negative 7? Negative 28. 3x times 5x, 15x squared. Right? So if we're working with large numbers, don't ever multiply them together. Just take those numbers and break them down a little further and look for factor combinations that work. And you might have to try some different combinations, but these, usually your first instinct ones are going to work. And that was our first instinct, right? Everybody would have said 28 7 times 4. Nobody would have said it's 14 times 2. That's just not, but that's the only other one that we would have to check. All right, let's do one more. Not that one. Let's do this one. What would you have to do first on this problem? Obviously, we need to take out a 3x, right? So let's take out a 3x. And that'll leave us with x squared minus 8x plus 12. And then we're looking for the factors of 12 that'll add up to be negative 8, right? What are they going to be? Negative 6 and negative 2. They have to both be negative because they're multiplying to get a positive and adding to get a negative. Okay? Homework. Take a picture of that. That's your homework.